Today we want to look at how we can verify Hooke's law. Hooke's law, and we said that Hooke's law states that the force applied to an elastic material is directly proportional to the extension or compression produced, provided that the elastic limit is not exceeded. How can we prove this experimentally? We need our meter rule to determine the original length of our elastic material and the extension produced by applied force. We need our masses which will exert the force. These are the masses which will exert the force. Also, we need a pointer, as you can see here. This is a pointer, and you need the elastic material itself. In this case, we are using a spiral spring. You can see it here. This is a spiral spring. So, what are the procedures for to verify Hooke's law? The first thing you do, you set up the experiment as you can see on the screen. You set up the experiment this way. Then you will determine the natural length of your spiral spring or the original length of your spiral spring and tag it S naught. Look at it. S naught. First of all, that means when the spring has not been loaded, what do you do? Determine the original length or the natural length. In this case, you see the position, you mark it there. If it is 50 and whatever it is, you mark it in centimeter. After you have done that, you are now going to suspend a mass depending on the teacher teaching you or the question you are solving. Suspend a mass, for mine a mass of 50 gram. Once you convert 50 gram to Newton weight, you are going to get 0.05. Is that clear? First of all, convert gram to kg by divided by 1000. Then times by 10 to get weight, because weight is equal to mg, where 10 is the acceleration due to gravity. Are we following? So look at the mass. With the help of the mass anchor, this mass anchor is already 50 gram. So you suspend it. Do you see it now? As you suspend it, you find that there will be extension. Is that clear? There will be extension. You are going to read the new position of the meter rule. You record it here of the pointer. You record it here. Is that clear? Then you now to get the extension. You are not going to what? Subtract the original length from it to give you extension. I get it. Then if you watch now, it increase. You put another 50 gram mass again on it. You will see the extend. You know, Hooke's law said that the extension is directly proportional to the applied force. So this is kg. Of course, we can still combine the force if you so desire. Do you get it now? You see that the more you are putting mass, the more the spiral spring will be extended. Is that clear? To a certain limit, which we call the elastic limit. In as much that this spring have not reached the elastic limit, the extension will be proportional to the applied force or the load. Is that clear? And this will showcase itself when you plot your graph. You are going to have a straight line graph. Is that clear? So I'm going to leave it to do this one. So you are going to take it to the lab session, carry out the experiment and plot your graph. Let's look at the shape of the graph. Once you plot your graph, you also determine, you plot a graph of n on the vertical axis against the extension on the horizontal axis. Then determine the slope s of the graph. Then evaluate k equal to 9.8 s, where s is the slope. Is that clear? Whatever you get, you see. Thereafter, I will give you the significance of the slope. Thank you.